NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is now more mysterious and more beautiful than humanity's dreams. When the world first started to notice incredible images of the cosmos, the strong James Webb Space Telescope was captured. This is the telescope that NASA launched. Its massive endeavor has changed the way we interpret the cosmos by returning a sequence of startling new images. These most recent images have stunned scholars and romantics, sharing little wisdom that contradicts what is already conjectured and creating new fields of research unmatched by anything we've done. You notice that these images provide us with a quick glance at the most remote and mysterious regions of the cosmos, pushing the boundaries of our understanding to usual areas. The James Webb Space Telescope was designed to take on the role of more than ever before the Hubble Space Telescope standards, with its sophisticated infrared characteristics that enable it to compare more deeply than any other instrument in the cosmos. Hubble provided unique perspectives on the universe's unseen light. The telescope mostly operates in an infrared range, making it possible to cut through dust from star clouds and solve the riddles of star development in the early universe. The creation of the telescope's most recent images has shown areas of the universe that were previously concealed from us, providing fresh details on events that have long baffled specialists in space. One of the most important images that the JWST sent back reveals an area of space that is so far away it passes a few 100 million years ago at most, following the Big Bang. This era in cosmic history is regarded as the Dark Ages, a time when the majority of the cosmos was obscured by enigmas during the first star's formation and the emergence of galaxies. Scholars are seeing evidence of these ancient structures with exceptional clarity, enabling them to organize the incidents that in some cases formed the early cosmos. Fresh images of dense gas clouds and dust nurseries are seen, areas that give birth to stars among the most chaotic and violent in the cosmos, where gravity organizes enormous quantities of material to ignite the nuclear processes that result in stars. JWST is able to record minute details of this process, displaying stars in various phases of their growth and providing a peek into the star's life cycle in a manner never before achievable. By looking at these images, cosmologists can discover the circumstances under which stars are born and the ways in which these processes have evolved, spanning billions of years. Together with stars, the James Webb Telescope has moreover obtained pictures of a great number of faraway planets that have never been observed before. These universes are situated at such a distance that their light has reached us after billions of years, indicating that we see things as they emerged when the cosmos was still in its inception. The telescope's unparalleled resolution has shown intricate internal structures in these galaxies, enormous black holes present in their distant star clusters and centers older than the Milky Way we live in. These black holes are especially intriguing because they contradict what we currently know about their formation and evolution. Several black holes shown in these images are somewhat bigger and quite busy considering their age. Hypotheses on the history of the universe suggest that black holes often begin as compact, thick objects that progressively gain mass over time by consuming the surrounding material. According to the JWST data, certain black holes can have grown completely, showing a sharp increase that forces cosmologists to re-evaluate their assumptions. Images of the evolution of black holes in these primitive galaxies also raise questions about how galaxies function, form, and change. Some galaxies witnessed by the JWST are extraordinarily well arranged, with clearly distinct spiral arms, and despite being so young, their centers bulge. In cosmic terms, this degree of arrangement is as astounding as it was once thought that galaxies in the early universe would be more disorganized and asymmetrical due to the intense processes that go into their creation. The finding of these perfectly shaped galaxies suggests that galaxy formation may have happened much faster than previously believed, which has substantial ramifications for our understanding of the early universe. The JWST has also offered a breathtakingly original viewpoint on one of the most mysterious elements, exoplanets. Exoplanets are planets that orbit stars outside of our solar system. While hundreds of exoplanets have been found in the last several decades, we still don't know much about their atmospheres or capacity to sustain life. The James Webb Telescope's capacity to detect infrared has allowed scientists to examine the chemical makeup of exoplanet atmospheres with more detail than ever before. Some of the additional images and information have produced unexpected results, including the existence of water vapor, methane, and other chemical substances. These findings are thrilling because they advance our progress in addressing one of the most significant inquiries in science: we alone in the cosmos. The presence of organic compounds in an extraterrestrial atmosphere does not necessarily imply that these planets support life, although it suggests that the fundamental components for life are more abundant in the cosmos than originally believed. These findings could eventually result in the identification of livable planets perhaps outside our solar system, changing our perspective on life and the cosmos. The latest JWST images also provide insightful explanations for the outcome phases of a star's existence. The telescope has detailed images of supernovae recording remains of enormous vibrant gas clouds and dust left behind after a star's explosion. These remnants are not only beautiful but also noteworthy from a scientific standpoint, as they are the locations where several of the universe's heaviest elements are produced. When a star explodes in a supernova, it releases a massive quantity of energy that combines lightweight components such as helium and hydrogen into heavier ones like iron, carbon, and oxygen. After this, the components are dispersed across space, joining planets, new stars, and ultimately existence itself. The James Webb Space Telescope's fresh images, which explore the early stages of the universe's existence, have opened a portal into a galactic tale that we could hardly understand before. What makes these images poignant is not just their beauty, but also their ability to reveal the universe's mysteries that were previously completely out of reach. These sights of remote places, never before seen nebulae, and cosmic structures in galaxies are forcing us to reconsider our beliefs that we understood the cosmos. Images of far-off galaxies and unusual occurrences have captivated the public imagination. One of the greatest and most incredible findings revealed by the JWST includes items that are much closer to home, the distant regions of our solar system. The infrared sensors on the telescope have the ability to research the frigid worlds at the solar system's boundaries, revealing fresh information on their makeup and surface characteristics. For example, the telescope produced a clear picture of Pluto's moon Charon, unveiling a multifaceted scene of mountains and frozen ranges that had not been seen before. These findings about the outer solar system might aid scientists in comprehending how planetary bodies originate in chilly, far-off places in space. The Kuiper Belt, a hybrid circle of vast areas of space outside of Neptune, is home to hundreds of frozen objects and has long been a source of intrigue for astronomers. The JWST's capacity for study by examining these objects closely might provide fresh knowledge about the formation of planets and the distances seen in planetary systems, offering hints about how our own solar system was created. Beyond the individual discoveries, the James Webb Space Telescope is also assisting in addressing one of the most important cosmological questions: how did the cosmos come to be? Its observations of planets, stars, and galaxies at various phases of their evolutionary journeys are helping build a cosmic history timeline. JWST's observations enable scholars to follow the formation of stars and galaxies billions of years in the past, offering a more complete picture of the history of the cosmos, both present and future. A crucial finding from the most recent JWST images is the awareness that the early cosmos was much more active than previously believed. The images depict galaxies developing at a quicker pace than anticipated, combined with intense bursts of star formation that occur in rapid succession. This challenges the enduring belief that the initial universe was comparatively calm, suggesting instead that the initial several hundred million years after the Big Bang were a period of exceptional activity characterized by rapidly developing galaxies and changing methods that scientists are only beginning to comprehend. The capacity of the James Webb Space Telescope to look back so far in history is primarily due to its extraordinary sensitivity. By looking in the infrared spectrum, the telescope is able to find even the smallest signs of photons that have traveled billions of light-years across space. This light released by galaxies and stars in the early universe has expanded and redshifted across time as the cosmos has expanded. The JWST's capacity to grasp this allows scientists to see ancient light from objects whose light is so far away it has absorbed almost the entire age of the cosmos to reach us. Along with gazing far back into history, the JWST is also offering a fresh view of the universe's own structure. Images show enormous cosmic webs, galaxies, and structures extending across the cosmos, resembling a spider's web. These networks generated by gravity form the core of dark matter's role in the large-scale structure of the cosmos. Scientists want to map these structures to understand dark matter's function in galaxy development and evolution. The JWST images provide a better understanding of these massive networks than ever before, offering fresh hints about the composition of dark matter and its influence on the cosmos. As the James Webb Space Telescope continues to operate and return updated pictures, it's becoming increasingly clear that we are entering a new phase of cosmic discovery. The telescope's ability to look further and more distinctly than any tool before is transforming our comprehension of the cosmos, offering responses to classic queries, while each new image raises fresh ones. We are presented with a universe that is more complex and more beautiful than we could have ever dreamed, abundant in wonders that defy our comprehension of spacetime and the essential elements. Among the most fascinating of these recent findings are those that question accepted notions of cosmic evolution. For instance, consider the idea of cosmic inflation, a rapid expansion of the cosmos just after the Big Bang. Observations from the JWST hint at the existence of massive structures that could only be explained by acknowledging an active early universe that was evolving rapidly. The boundaries of our knowledge are being expanded by the JWST, not just because of the technical advances that make its observations possible, but also due to the new narratives it weaves into our understanding of existence itself. Every image returned from the JWST inspires a sense of awe and wonder, urging scientists and enthusiasts alike to think about our place in the vastness of the cosmos. The countless galaxies, ancient stars, and nascent planets depicted in its images all tell the stories of billions of years of cosmic history. As we delve deeper into the cosmos with the James Webb Space Telescope, we are embarking on a journey of discovery that will redefine our understanding of space-time and everything in between. With each new image, we are reminded that the universe is not just a distant collection of stars and galaxies, it is a vibrant tapestry of cosmic history where every thread is connected to the fabric of existence itself. The telescope serves as a bridge between the past and the present, offering glimpses into the mysteries of the universe that are just beginning to unfold. With its incredible capabilities and the breathtaking beauty of its images, the JWST invites us all to gaze up at the night sky and ponder the profound questions of our existence, igniting the human spirit of curiosity and wonder.